All right, well, I'll get started. Probably I should show you another example of the long division. Let's see here. So, here we go. We'll do 4y cubed plus 6y squared plus 14 divided by 2y plus 4. All right, so you can help me out here. How do we get started here? So to get the 4y cubed, we should multiply 2y by what? 2y squared. Very good. So we'll do a 2y squared. And so that times that gives me 4y cubed plus 8y squared. Right? Subtract. And that gives me minus 2y squared, right? Plus 14. All right. And then, all right, so I want to get rid of that from this. So I do what? Minus y. So that gives me minus 2y squared minus 4y. Careful with the minuses. These cancel. This gives me 4y plus 14. All right, so then what? How do I get rid of this with that?
Sorry, I was trying to figure out that there was two minuses, so you had to add those two.
Right, yeah.
Do 2y.
2y? Okay.
No, just 2.
Oh, plus 2, yeah, very good. Plus 2, that gives me 2y, oh, excuse me, the 4y plus 8, great. And we get 6, 6 is our remainder. So what's this calculation tell us? This calculation tells us that 4y cubed plus 6y squared plus 14 divided by 2y plus 4 is equal to 2y squared minus y plus 2 plus the remainder 6 divided by 2y plus 4. There you have it. So this is long division. Now, if we hadn't missed as many Fridays as we've missed lately, I would have time for more examples of this, but sadly we've missed some classes, haven't we? And so I did promise that I would try to show you guys the synthetic division. Well, yeah.
Why didn't you just show it? You showed us some stuff that was
Oh, well, yeah, I think long division and synthetic division are potentially on the test. I do think that I wouldn't test synthetic division. I wouldn't force testing of synthetic division. Like, you could use long division to do the synthetic problem if you wanted, is my intention, yeah? So what I would say is if you understand long division carefully, you can do everything. If you understand synthetic division carefully, you can only do special cases. So, but nevertheless, people insist that synthetic division is a good method for students in here, so let me show it to you. So here's an example. I guess this is example 2. I'm going to illustrate the method of synthetic division. so this example is from your textbook. And so we're going to do 2x cubed plus, why is it so hot in here? 7x squared minus 5 divided by x plus 3. All right, so here's how the synthetic division goes. You draw a little thing like that, and you put minus the number of whatever that is here. So since there's a plus 3, put a minus 3 here. And then you write the coefficients of the polynomial here. So there's a 2, there's a 7, right? And then here's where it gets a little bit tricky. There's no x, right? So we got to put a 0 because the coefficient of the x term is 0. And then minus 5. All right? Then we draw a line down here. All right? So far I've done really no calculations, okay? So step number 1 is we bring the 2 down to here. All right? And then, let's see here. We write a minus 6, right? So 7 take away 6 gives you what? 1. I think I'm doing it wrong. Just a second here. All right, let me go back to page 391. Try to follow their rigmarole here. So, all right, so you bring down the 2, and then so we multiply okay, we multiply 2 times, this is what we do. This times that gives me minus 6. I put that there, right? And then I subtract these. That gives me 1. And then minus 3 times 1 gives me what? Minus 3. So I put that here. Subtract that. That gives me 3. Minus 3 times 3 gives me minus 9. I put that here. Right? And then this minus that gives me 4, I think. Yeah? And yeah, that's what they have written. Oh, wait a minute. Minus 3? What the what? Oh, we add these. I'm a dummy. Add. So this would be what? Not... Well, first of all, then that would be 9. Yeah. 9 and 4, okay.
Well, wouldn't you add the 7?
I do, yeah, that's the thing is I did add it, yeah. And then they put a little bar here to tell you that's the remainder. And these are the coefficients. And if you're dividing a cubic by a linear, then it's going to be 1 power less. So it's going to be 2x squared. So we have 2x cubed plus 7x squared minus 5 divided by x plus 3 equals to, excuse me,
2x squared plus x times 3.
All right. So let's try to do this one with the synthetic division. Huh. Huh. Yeah. Well. Let's try to stay out of trouble. So instead of doing this problem, we can divide the top and bottom by 2, right? This is equal to 2y cubed plus 3y squared plus 7 divided by y plus 2. You factor out 2. I mean, it's very silly. I don't know why this problem was given as it was, but now this I feel more confident about trying the method of synthetic division on. All right, so let's try synthetic division on this thing. It is, after all, equal to that, so, all right. So we get, right, put -2 up here, draw our line. So we bring 2 down here. That gives me -4. Add them, -1, 2, 2, -4, 3. Whoa. Oh, hey. This is not wrong. Look, so we get 2. So this gives us that y cubed, 2y cubed plus 3y squared plus 7 over y plus 2 is equal to, this is all equal to what? It's equal to 2y squared minus y plus 2 plus 3 divided by y plus 2. I was like, that doesn't look like the same answer, right? But look at this. This guy and that guy are actually the same answer. It's manifestly clear, 2y squared minus y plus 2, right? But the fraction is, you notice you can factor a 2 out. You got 3 times 2 over 2 times y plus 2. So if you cancel the 2 in the numerator and the denominator of this guy, it's the same fraction. So listen, whichever you're more comfortable, I will fully agree that if you have a mastery of synthetic division and you want to do problems like super quickly, it's not a bad method, right? Because there's less writing, right? So it's faster. But my own personal preference is to always use long division. The other problem is just one more example of division, then I'll stop for today. If I was dividing by something that wasn't a linear thing, if I was dividing by something that was higher order, I just can't do synthetic division. Synthetic division is for linear division, division by linear factors. So here's an easy enough example. If I'm dividing x cubed plus 1 into x to the 5th plus 6, like I can't use synthetic division for this one. But with long division, it's not too hard. Like I just go, okay, well, x squared. This gives me x to the 5th plus x squared. Subtract. I've got, minus x squared plus 6. And that's my remainder. Okay, so, yeah. There you go. X to the 5th plus 6 over x cubed plus 1 equals, x squared. Yeah. Right. There you go. So now, if you want to see more examples of me working out long division, there are hours of this in previous iterations of this course to watch if you're interested. If you already get it, then great. If you need help finding the videos where I've taught this in a previous course, just email me. I'll find them for you if you want me to. Okay, so let's look at some other examples. Let's look at some complex, these are called, this is section 5.4 on quote-unquote complex fractions. So let's do some examples here. Example 4. So here we've got a cubed over b to the 5th divided by a to the 4th over b squared. How do we simplify this? We go, that's a cubed, b squared divided by a to the 4th, b to the 5th, right? So this guy moves upstairs, this guy moves downstairs, and these a cubed and a to the 4th stay put. And then, let's see here, I'll keep the positive exponent. So this is going to give me 1 over a b cubed. So if you like, I could do it this way. A to the 3 minus 4, b to the 2 minus 5, a to the minus 1, b to the minus 3. Or you could do it 1 over a, 1 over b cubed. You know, there's a lot of different things we could write here. The book thinks that this is the answer, so there you go. All right. Let's look at another one. Example 5. Here I've got x minus 1 over x divided by x plus 1 over x. We're asked to simplify this. And so when you're asked to simplify a compound fraction, what they want is they want you to make it into a simple fraction. A simple fraction is one that just is a one numerator, one denominator. It's not a fraction of fractions, right? What would you do here? I'm going to get my eraser shirt. Any ideas? How would you clear out those fractions?
I didn't see one of these in the homework.
There were none of these in the homework? You've done all of them?
I've done all the section. I didn't see none of that.
Ah, maybe this is the section they wanted to get rid of. Oh well, I'll finish this one. So this, what you want to do is just multiply the top and the bottom by x.
Okay.
And then when you multiply through, you get x squared, x over x, which is 1, and then x squared, x over x, which is 1. So yeah, I mean, these aren't bad. I'm not sure why we took them out if we did. Maybe it was just that there's a lot of students that...
I got one that looked like that. It just had numbers and numbers.
Oh yeah, there are also ones with numbers.
I did the homework.
I got you. Let's see here. So let's look at some more of these. Let's see here. Example 6? I can't remember. So 1 over x plus 2 plus 4 over x minus 3 divided by 2 over x minus 3 minus 7 over x plus 2. This is like number 23 from section 5.4. Again, my apologies if these aren't in the homework. I hope me showing you a couple of them in class makes it a reasonable test question. I don't think there's going to be like a bunch of these on the test, but there might be one, you know? So, all right. So what do you do here? So like before multiplying by x, fix things, right? So you look at it, you go, I got denominator with x plus 2, I've got denominator with x minus 3. I need to get rid of those, right? So the way to fix this one is to multiply the top and the bottom by the same. We have to multiply the top and the bottom by the same, right? Otherwise it's not fair. So we're just multiplying by 1 is what we're doing, yeah? But we're multiplying by 1 in a smart way. And see, so when you multiply this through, this x plus 2 and that x plus 2 cancels and leaves you x minus 3. This x minus 3 and x minus 3 cancels, and it gives you 4 times x plus 2. And then down here, this x minus 3 and x minus 3 cancel. Yeah, 2 times x plus 2. Right, don't lose the minus, of course. And then you can clean things up a bit, right? So that's x minus 3 plus 4x plus 8, 2x plus 4 minus 7x plus 21. And we got ourselves a what? A 5x plus 5. Downstairs what? Minus 5x plus 25. Ooh. I feel like we should simplify that. Just otherwise it feels wrong. That's 5 times x plus 1 over 5 times 5 minus x. So it's x plus 1 over 5 minus x.
Bottom, where you get 5 and then 5 minus x.
Mm-hmm.
Don't that need to be flipped so you get negative 5x plus 25?
Why would it negative 5x plus 25? That's what I have. This is equal to. You can write the addition in a different order.
Okay.
That doesn't change it, right?
I didn't know if it
No, it does. Addition commutes. So like the addition you can flip around. I just did that because as a point of personal style, I like the minus to be in the middle. It's like, but anyway, that is the answer in the book for what it's worth. So yeah. All right, let me move on to section 5.5, which I think is probably a more important topic in the big scheme of things. Because here we finally, so up to this point, what I've been doing, I've been showing you how to manipulate expressions, right? How to simplify them. So what else comes after that is how to solve equations, right? And the solution of the equations involves all the skills that we've been working on here, right? So I'll start at the beginning. I'll start at the number 1 here in section 5.6. Let's solve y over 10 equals to 2/5 plus 3/8. So how are you gonna solve something like this here? So what I do when I see something like this is I let my hatred of fractions guide my steps. I think to myself, what number can I multiply this equation by to annihilate all of the fractions, to get rid of them, right? So what jumps off the page of me here is if I multiply by 40, it's going to do the trick, right? Because like 40 over 10 is 4, 40 over 5 is 8, 40 over 8 is 5. So if I multiply this whole equation by 40, that gives me 4y equals to, again, 40 over 5 is 8. So 8 times 2 is 16. And 40 over 8 is 5, so that gives me 5 to 15. Right? So 2/5 of 40 is 16. 3/8 of 40 is 15. That's 31. So y equals 31 over 4. Now, I mean, let me show you, if that was weird, the way I did that just now, if that was weird to you, let me just read.
It's not weird, it just took me a minute to realize what you were doing.
Oh yeah, sure, sure. I think I did it a kind of weird, that's not actually how I typically work that kind of problem. I mean, like, so if I was going to do, let me do that problem again, just like a slightly different way. I'll change the letter to x. There, that makes it a different example, right? X over 10. 2/5 plus 3/8, yeah? So how I typically work this problem is just to convert the fractions, like make a common denominator. The fractions, you know, this is what? This is, in terms of 40, it's 8 over 8 times, I multiply this by 8 over 8, you know? Here's what I think about in my head. 8 over 8. And I multiply this one by 5 over 5, yeah? And that gives me 16 plus 15 divided by 8. In other words, 31 over 8. So then I've got x over 10 equals 31 over 8. So what do? I solve for x. X is equal to 31 over 8 times 10, yeah? And what's that work out to? That does not seem right. 155 over 4, huh?
38.75, which one you want?
I want something that's not different than my previous problem. Yeah, so yeah, I agree. 155 over 4. How did I not get 155 over 4 down here? I must have made a mistake, yeah?
Because you stopped at the 31 over 4. Start at 31 over 4. Times by what? Same thing? You know what I'm saying?
What's that?
So why on the bottom did you not?
Oh, I know the problem. I know the problem. This was not an eighth. What was this? 5 times 8, yeah? This was supposed to be 40. My bad. That was 31 over 40. See? Sorry. Now it's obvious, right? So the 10s cancel and you get 31 over 4. We should not get a different answer for doing it a slightly different way, yeah? I mean, even if we do it a really different way, we shouldn't get a different answer. It's math, right? Your life experiences really shouldn't figure into it, you know? All right, so example 9. Let's solve something a little bit more interesting. X minus 6 over x plus 9 equals to 2/7. How do we solve this? So I solve this by cross multiplying. So I multiply 7 over here, and I multiply x plus 9 over there. So yeah, 7 times this is equal to 2 times that, right? Which gives us 7x minus 42, 2x plus 18. Now you want to isolate the x. So we get 5x equals to 18 plus 42, which is 60. So x is 60 over 5. also known as 12. So these kind of problems, what we want to do is we want to like cross multiply and then just work it out. Let's see here. I can find one that's a little bit, find one that's a little bit different. Example 10. Here we have x over x minus 2 plus x over x squared minus 4 equal to x plus 3 over x plus 2. This is number 25 from section 5.5. I think obviously this one's a little bit harder than the one we just worked, isn't it? Right? There were no word problems in your homework, right? Okay, good.
I literally quit if there's word problems.
You just quit? You just quit if there's word problems. You just cracked me up. Let's see here. Okay. Well, I think this is it for chapter 5 in terms of the non-word problem part of the chapter, yeah. So if we can solve this one, we're pretty well ready. Again, I would encourage you guys to work through the review with me on Friday, so you'd be ready for the test Monday, yeah. Or by yourself is even better. So, what do I do here?
You don't want to make it
Cross multiply both of them. I mean, that's not a bad. But the thing is, I can't cross multiply unless I have like one fraction, yeah.
Yeah.
So how? I mean, but we could make this into one fraction by doing what? Like by multiplying x times x plus 2. Well, I'm skipping too much. Sorry. Skipping too much. My point is, this is x minus 2 times x plus 2, right? So to make this a common fraction, I just need to multiply the first one by x plus 2 over x plus 2. And so I have x times x plus 2 plus x over x minus 2 times x plus 2 equals to x plus 3 over x plus 2. And then I can cancel this and that. And I can multiply this over there, and I get myself an x squared plus 2x plus x is equal to x plus 3 times x minus 2. Do you follow? So I multiplied out the numerator here, and I multiplied the denominator to the other side, giving me this. Then, of course, this is x squared plus 3x, and that is x squared plus 3x minus 2x gives me plus x minus 6.
Take care of your x's on one side.
Oh, I was hoping for a quadratic equation, but I'm now disappointed. It's not a quadratic. I mean, in general, these kind of problems could land you to like a quadratic equation, you know? Didn't happen to us here, though. So, yeah, these cancel, don't they? Subtract them from both sides, and we're just left with 2x equals to minus 6. So x equals to minus 6 over 2 minus 3. Now, to be careful, you should really go back to the original problem and make sure it makes sense, because whenever we do kind of stuff like, whenever we like multiply one thing to the other side or cancel out like factors, if those factors happen to be 0 for our answer, that would mean that our answer was actually probably not allowed. But if I go back to -3 and plug it back into the original equation, everything's fine. I get like, you know, -3 over -5, so I get 3/5, and then -3 over -4, so 3/5. So I get 3/5 plus 3/5, which is 6/5. On the other side over here, I get 0? What the what? Oh man. Whoa. Whoa. Dude. I did something wrong there. I should have got 0 on both sides. Oh. Look. This is plus 3/5. This is minus 3/5. So this and this plus this is 0. And that over here is also 0. 0 equals 0, it checks. Yeah, so, you know, checking your answer only works if, you know, you actually check it with correct arithmetic. I think we got time for one more in here. Let's look at one of these problems towards the end of the section that's stated a little bit differently. Whoa. Quiet, Google. You're trying to get me to share my opinion. All right. Well, that's exciting. So here, yeah, right. F of x equals to 2x minus 15 over x, okay? This is a function, all right? And then it says find all x for which f of x is equal to 1. Now the answer to this one, it's got 2 answers, which gives me hope that this one is going to land us to a quadratic equation once we sort through it. All right, let's see how. So what is this saying? This is saying set the formula equal to 1 and see what x makes it so. How do you solve this equation? What are we going to do? Plug 1 in.
No, is that not right?
Well, if it worked, you got lucky. I mean, guessing is always an option, but that's not where would not be my original approach. Although it would work well for me since I know the answers.
No, kind of answer real quick. See if it works.
The answer was 3. Okay. Okay, so that's one of the answers. There's another one. Okay, so this one, we don't like this, right? But this is easy to fix. To make a polynomial equation, we can solve polynomial equations with factoring, right? Quadratic equation, all that good stuff. So multiply by x. Multiplying by x, so we have 2x minus 15 over x times x equals to 1 times x, right? Which gives us 2x squared minus 15 minus x, well, equals to x, right? Or 2x squared minus x minus 15 equals to 0. So let's see here. Well, I know I'm going to put a 3 there. So that must put a 5 here. Did that work? You got yourself a minus 6x plus 5x minus x. Yeah. And of course you could use the quadratic formula there if you didn't see that, or completing the square, better yet. And so our solutions are x equals to minus 5/2 and 3. Which is what the book says. But no, I wouldn't advise guessing for these. Like I mean, you might get lucky, but well, I don't know. typically the answers to algebra questions that we ask in here are numbers between 1 and 10. There's a decent chance you can guess the answer. It's not wrong, but
Mine can't believe it.
oh, yeah. So yeah. Any questions? All right, well, I'm going to go try to get the review put together for you guys, and I hope to have that posted today. And then hopefully I'll work through it on a video I'll post Friday. All right, don't forget, test is Monday.